Hi, this is Francis from A+ Tutoring. In this session, I'm going to show you how to use ratio tests to find if the series is convergence or divergence. Now, if you look at this problem here, you have something that is n, and you have some exponential that is to the power of n something, then you can actually choose to use ratio tests. Now, ratio test is saying that when you take the limit of n approaching to infinity of the next sequence over the current sequence, then if this limit is smaller than 1, then it's convergence. Bigger than 1 is divergence. If it's equal to 1, then it's inconclusive, so that you have to find another test to figure out if it's converging or diverging. Now, in this case, what I'm going to do is to take the limit of n approaching to infinity of the next term. What does it mean is basically n plus 1, replacing all the n by n plus 1 to the power of square 2 to the n plus 1 over 3 to the power of n plus 1, and divided by the current term, which is n squared 2n plus 1 over 3 to the power of n. Now, if you have something like this, then you have to, if it's dividing a fraction, then it's multiplying the inverse, right? So let me rewrite everything here. Limit of n approaching to infinity, absolute value, n plus 1 to the power of square, 2 to the power of n plus 2 over 3 to the power of n plus 1, multiply with 3 to the power of n over n squared, 2 to the power of n plus 1. Now, how can we simplify this? If you look at 2 to the power of n plus 2 and 2 to the power of n plus 1, this basically cancel out with the exponential here. All you have left is the 2. Now, same thing here. This is cancelled with only a 3 at the bottom. And now you have n squared and n plus 1 squared here. So let's rewrite this limit here. Limit of n approaching to infinity, n plus 1 to the power of 2. I have an extra 2 in front because that's a coefficient over 3n squared, absolute value. Now, if you remember the trick that I have shown you in the previous video, when n is approaching to infinity, you take the highest degree on top and highest degree at the bottom. If they have the same degree, which in this case, the degree on top is 2, the degree at the bottom is 2, they have the same degree, then we just take the coefficient, and that will be our answer. So this is going to be 2 over 3, which in this case is smaller than 1. Now, if you look at this here, if it's smaller than 1, that means it's converging. So this series converges. So therefore, it converges. Now, we don't know what is the sum that is converging to, but we know that the series is converging. For more information about ratio tests, please visit my website, goforaplus.com.